Hey everyone, in a new awesome video, and today we're going to start with a new series of videos about classical mechanics. The plan is to start with the most basic concepts and slowly but steadily build it up towards the most complicated topics of this branch of physics. To follow this series of videos, you need to have a general understanding of singular variable calculus because it will be a really useful tool for us. Today, we're going to explore these three concepts: coordinate systems, position vector, and distance versus displacement. Great, so let's start with coordinate systems. Imagine you have a field with a tree, the ground, and you also have a ball on it. One of the most basic things you might want to know about the ball is its position. So I ask you, where is it?
Over there. Right there. At the right of the tree.
There you go. Every time you want to communicate to someone the position of something, you need to select a reference frame. In our case, we'll mark the tree as our origin. And now, to the question of where is the ball, we'll say to the right of the tree. But wait, there's a problem to this. Imagine we have another ball over here. We're going to draw it in red. And if we ask the position of this other ball, it's also the right of the tree. But then, how can we distinguish between them? We need to somehow mark the distance between the tree and the balls. To do so, we'll make some marks on the ground. Let's say the blue ball is at 2 steps from the tree, and therefore the red ball would be at 4 steps from the tree. Alright, but there's still another problem. Imagine we have another ball over here, and if it's also the right of the tree, and if we measure its distance, it seems to be also at 2 steps from the tree. But it is obviously not the same position than our first blue ball. To deal with this, we need to define a direction for our steps. We'll do so by drawing a unit vector. By the way, we'll make it of the same length than our steps. That way, we have a fixed step size. Apparently, this system has no more flaws. But wait, this seems familiar. This is a coordinate system. The tree is our origin. I had our unit vector and the ground our axis. Now that we have our ball and a way to measure its position, we'll establish a new idea: the position vector. You can think of the position vector as a set of instructions, a map, on how to go from the origin to our ball. In this case, we'll draw it over here, blue, and we'll call it R. What is the advantage of using vectors? Well, imagine we have another ball over here with a different position vector, in which case we'll call it S. If we want to know what is the position of one ball with respect to the other, that is, this vector, t, everything we'll have to do is to subtract one vector from the other. T will be equal to S minus R. And that's why we use position vectors. The last concept we're going to introduce in this video is that of the difference between distance and displacement. Distance works the same way as in our usual life. Imagine you are in your house and you decide to go for a walk. You go over this long path and you come back. And imagine this path is 1 kilometer long. Let's symbolize that. Alright. Then we'll say you have covered a distance of 1 kilometer. But displacement is a little bit trickier. To understand displacement, we need to draw a reference frame. So let's draw our origin over here. At the start of our walk, our position vector will be in our house. Let's call it R. Just around the middle of our walk, our position vector will be over here. And we'll call that R prime. If we want to know the displacement in this time, we need to subtract these vectors. R prime minus R. And our displacement would be this vector. And it will be called delta R. So this displacement isn't the same as the distance, as this distance is completely different. And if you go till the end of our walk, once our new position vector is right on the door of our house, let's call that R prime prime, our total displacement would be 0. These are the most basic concepts we are going to use on our analysis of classical mechanics. Remember that you can subscribe to the channel so that you don't miss any of the videos. I hope you liked it and see you another day with more Physicawesome.